Good morning, all. I am Ajayna Desai, Research Scholar of Model Engineering College, Trikakara. On today onwards, I am going to take the fifth module of Signals and System. This is my overview of the lecture, and it is not completed, so it will continue to a somewhat extent. The fifth module of your Signals and System contains the syllabus Z transform, and the corresponding syllabus is this one. It includes Z transform, ROC, inverse Z transform, its properties, unilateral Z transform, relation between DTFT and Z transform, analysis of discrete time LTI system using Z transform, transfer function, stability and causality of Z transform. In the second and third module, we have covered the Laplace transform. Z transform is the discrete counterpart of Laplace transform. In the Laplace transform, the continuous time signal is represented in the Laplace domain or simply S domain, where S is a complex variable and this complex variable is represented in the rectangular format as S is equal to sigma plus j omega, whereas the Z transform is introduced to represent the discrete time signal or a discrete time sequence in the Z domain. Here, the Z is the complex function and is represented in the polar format as Z equal to r e raised to j omega. In the Laplace transform, the concepts of system function is represented for the continuous time LTI system, whereas in the Z transform, the concepts of system function are presented for the discrete time LTI system. The x of n and x of z are said to be the Z transform pair and is represented in the given equation below. The Z transform of a discrete time signal is defined by Z of x of n is equal to x of z is equal to summation n is equal to minus infinite to plus infinite x of n into z raised to minus n. Here, as I said earlier, z is generally a complex valued and is expressed or represented in the format of polar one as z equal to r e raised to j omega, where r is the magnitude of z and omega is the angle part of z. The above equation defined in the equation number 2, that is x of z equal to summation n is equal to minus infinite to plus infinite x of n into z raised to minus n, is generally termed as bilateral form of Z transform or the two-sided Z transform, since the summation is ranging all over the integer values from minus infinite to plus infinite. Coming to the next topic, region of convergence. Region of convergence. The set of Z values for which the summation, that is summation n is equal to minus infinite to plus infinite x of n into z raised to minus n converges is called region of convergence or simply ROC of the Z transform, since The Z transform is a power series. It converges when x of n into z raised to minus n is absolutely summable. That is, summation n is equal to minus infinite to plus infinite, modulus value of x of n into z raised to minus n less than infinite. The region of convergence will be an annular region of the entire complex z plane given by r1 less than mod z less than r2. The lower limit r1 can be 0 and the upper limit r2 could possibly be infinity. Next, going to the properties of region of convergence, the ROC of Z transform consists of a ring or a disk in the Z plane which is centered about the origin. Second property is the ROC of X of Z does not contain any poles, because if it contains any poles, it tends to infinity value. If x of n is a finite duration right-handed sequence, which means that my sequence x of n is a causal sequence having finite duration, then the ROC of x of z is the entire z plane except z equal to 0. Let us go for an example. Let us compute the Z transform of x of n is equal to 1, 2, minus 1 and 3. Here x of 0 is 1, x of 1 is 2, x of 2 is minus 1, x of 3 is 3. So my general equation for x of z equal to summation n is equal to minus infinite to plus infinite x of n into z raised to minus n. Changing the limits of n, so summation n is equal to 0 to 3 x of n into z raised to minus n. So x of 0 is z raised to minus 0 plus x of 1 is z raised to minus 1 plus x of 2 is z raised to minus 2 plus x of 3 is z raised to minus 3. So substituting the values of x of 0, x of 1, x of 2 and x of 3, we get x of z as 1 plus 2 is z raised to minus 1 minus 2 is z raised to minus 2 plus 3 is z raised to minus 3. So in this equation, x of z tends to infinity when z raised to minus 1 or z raised to minus 2 or z raised to minus 3 tends to infinite, or simply z raised to minus 1 tends to infinite, which means that 1 by z tends to infinite or z tends to 0. So ROC is entire z plane except z equal to 0. So this is my ROC. It does not contain 0, but it contains infinite value. If x of n is a finite duration left-handed sequence, or my sequence is an anti-causal sequence, then the ROC of the Z transform is entire Z plane except Z equal to infinity. Let us go for an example. Let's compute the Z transform of x of n is equal to 1, 2, minus 1 and 3, where x of 0 is equal to 3. So the general equation of x of z equal to summation n is equal to minus infinite to plus infinite x of n into z raised to minus n. That's equal to changing the limits of n. Summation n is equal to minus 3 to 0 x of n into z raised to minus n. That is x of minus 3 z raised to 3 plus x of minus 2 z raised to 2 plus x of minus 1 z raised to 1 plus x of 0 z raised to 0. Substituting the values, we get z cube plus z square 2z square minus z plus 3 will be my x of z. This equation will tends to infinite if the value of z tends to infinite. So the ROC will be the entire z plane except z equal to infinite. It also includes the zero value. When z equal to 0, x of z will be 3, which is means that it is finite. And if x of n is a finite duration double-sided sequence or a non-causal sequence, then the ROC of x of z is the entire z plane except z equal to 0 and z equal to infinite. Moving to an example, let us take my sequence x of n is equal to 1, 2, minus 1 and 3, where x of 0 is minus 1. Here x of z equal to minus infinity to plus infinity x of n into z raised to minus n, that is summation n is equal to minus 2 to 1 x of n into z raised to minus n. Substituting the values, and we get x of z as x of z equal to z square plus 2z minus 1 plus 3z raised to minus 1. Here x of z will tends to infinite if z uh, tends to infinite or z raised to minus 1 tends to infinite. So the ROC will be the entire z plane except z equal to 0 as well as z equal to infinite. So it does not contain the 0 value, also it does not contain the infinite value. Next property, if x of n is a infinite duration right-handed sequence, that is my sequence x of n is a infinite duration causal sequence, then the ROC of x of z is lying outside a circle in the z plane whose radius is equal to the largest magnitude of poles of x of z. Let's take an example to compute the z transform of x of n is equal to u of n. So summation, the general expression for z transform is summation n is equal to minus infinite to plus infinite x of n into z raised to minus n. That is summation n is equal to minus infinite to plus infinite u of n into z raised to minus n. As we all know, u of n is a function that's a step function and it varies in the range 0 to infinite. So having the values always equal to 1. So summation n is equal to 0 to infinite z raised to minus n, that's equal to 1 plus z raised to minus 1 plus z raised to minus 2 plus etc. tends to infinite. This is a binomial equation, and this equation will can be expressed as 1 divided by 1 minus z raised to minus 1 or z divided by z minus 1. The x of z will take the infinite value if 1 minus z raised to minus 1 tends to 0. That is 1 minus z raised to minus 1 equal to 0 and z raised to minus 1 equal to 0, and z will be uh, greater than 1 as it is a right-handed sequence. So it also includes infinite. So this is my ROC. If x of n is an infinite duration left-handed sequence, then the ROC of x of z is inside a circle in z plane whose radius is equal to the smallest magnitude of poles of x of z. Going to an example, let us take the z transform of x of n is equal to minus u of minus n minus 1. So this is a general expression for z transform. When substituting my function, we get as, or we obtain as, minus infinite to plus infinite minus u of minus n minus 1 z raised to minus n. Rearranging on the value of n, or the limits, this is equal to minus, and taking outside from here, n is equal to minus infinity to minus 1 z raised to minus n. On expanding this equation, z plus z square plus z cube plus etc., and this will be z divided by z minus 1, or which is similar to the my u of n. This is my similar to the u of n, z divided by z minus 1. So here the ROC will be mod z less than 1, as the as my sequence is a anticausal signal. It also includes 0 value. And next is, if x of n is a infinite duration double-sided sequence, then the ROC of x of z is a ring of finite with the z plane bounded between the poles of x of z. And the last property, ROC of x of z is a connected region. So this example has been already told. This is also explained. This one is also explained. So compute the z transform for an impulse function, that is del of n. So we know that my delta function is valued only for z equal to, sorry, x of n is equal to 0. When x of 0, the value will be 1, and all other cases the value is 0. So 1 is at raised to 0, that's a 1. So the ROC will be the entire reserve plane including 0 as well as infinite. This has been told. So obtain the Z transform of x of n is equal to a raised to n into u of n. So the limit of this is a general expression, as here here we having u of n, so the limit changes from n is equal to 0 to infinite, a raised to n into z raised to minus n, that is a z raised to minus 1 the whole raised to n, that is 1 plus a z raised to minus 1 plus a z raised to minus 1 the whole square plus etc., that is 1 divided by 1 minus a z raised to minus 1, and can be represented as z divided by z minus a. And the ROC will be mod z greater than a, since it is a causal sequence, and it also includes the infinite value. This has been explained. Next is minus a raised to n u of minus n minus 1. This is a general expression. I am substituting my signal x of n as minus a raised to n u of minus n minus 1. So a z raised to minus 1 raised to n. The limit of n will be from minus infinite to minus 1, that is minus of a z raised to minus 1 the whole raised to minus 1 plus a z raised to minus 1 the whole raised to minus 2 plus etc., and z divided by z minus a will be my x of z for this sequence. So the ROC mod z will be less than A. It also includes the zero value, but it does not include um, infinite, since it lying inside the uh, circle having a radius of A, since it's a um, anticausal sequence. So next is a transform of the function a raised to n u of n minus b raised to n u of minus n minus 1. We know that a raised to n u of n will having the z transform of z divided by z minus a, and the ROC is mod z greater than a, which has been explained in this slide number 15. And next is minus b raised to n u of minus n minus 1 having the z transform of z divided by z minus b, whose ROC will be mod z less than b. This is explained in this slide number 17. And combining both of these, we will get ROC as a less than mod z less than b. Thank you for your patience listening.